All right, well, next up we have solving the triangles. This comes out of our book from section 5.4. Another thing you may notice is that Trey still owes me a calculator, so help him find that if you could. But solving a triangle, remember, means I want the measures of all the angles and all of the side lengths. So if I've solved it, I know all of the information about it. You'll always have to be given at least 3 pieces of information. One of them is the 90-degree angle, and 2 of them could be 2 side lengths or 2 angles or a side length and an angle, like in this one. So first things first, I'm going to use the triangle sum theorem, which says that all of the interior angles of a triangle have to add up to 180. So angle A plus B plus C equals 180. Notice how I'm using the capital letters for the angles. The lowercase letters represent the side lengths across from them. We have 90 degrees for C and 26 here. That's 116. So angle B plus 116 degrees is 180. Subtract 116. Wait. Okay, much better. And then that is equal to 74? No, 64. Sorry. 64 degrees. So we got angle B is 64 degrees. And now we're going to find the different side lengths. So we're going to use our trig ratios. Unfortunately, we don't have the hypotenuse, which would be best. My favorite trig ratio is cosine. So I'm going to set up cosine with A, just arbitrarily. You can pick sine or cosine or tangent to start with, but I just like cosine the best. I don't know why. So I'm going to do cosine of angle A, which is adjacent over hypotenuse. I can fill that in with information that I know. So cosine of angle A is 120 over C, which is my hypotenuse. Now, for those of you who remember the little switcheroo trick, is kind of a shortcut. But these two, whenever you have your variable in the denominator, these are always going to switch places. If you don't remember that, put cosine of 26 over 1, and you can cross multiply. Be careful that you don't multiply by 120 on both sides, because our C here is in the denominator. And it's not undone by multiplying by 120. It's undone by multiplying by C. So when you cross multiply, you get C times cosine of 26 is equal to 120, and then divide by cosine of 26. C is equal to 120 divided by the cosine of 26. That's what it's equal to. Now you're going to have to get your trusty calculator and go beep, boop, beep, boop, beep to get an approximation that is meaningful to us. 120 divided by cosine of 26 is 133.5. You could also round that to 134 since B has been rounded to arguably the tens, but just rounded to ones here. So 134 or 133.5, I'll take either one. If you give me more decimal places, that's okay. I don't really care. Next. We good? Yeah. And now I'm going to C is Now we can go forward in a couple of different ways. I can either use another trig ratio with A. So I can choose either sine of 26 or cosine of 64 or tangent of either one to solve for A, or I can do Pythagorean theorem. We're going to do Pythagorean on the next one, so I'm going to do tangent of A just because I want to. So tangent of 26 degrees is opposite over adjacent, or A over 120. I'm going to multiply by 120 because what's happening to my variable is that it is being divided by 120. I undo the division by multiplying by 120. So that, in this case, that is going to cancel out. Back to my trusty calculator. Beep, boop, beep. And I'll get A is approximately 58.5. That's what our answer looks like. Now we have all of the angles, all of the side lengths. And again, to find these sides, you can use sine, cosine, tangent, and use either angle once you have both angles to find the missing pieces of information that you're looking for. It's arbitrary.